Good morning to all. Today we will see the topic of dimension analysis. So this topic that is used in fluid mechanics to solve the different equations. Okay. Whenever they were having two equations, there were two equations and side has to be balanced so that it can find out which parameter is directly proportional or indirectly proportional analysis. So we will learn about these equations now. For every equations, for every parameter, there will be some dependent and independent parameter. Okay. For our dependent parameter, we cannot change the variables or you cannot adjust your values. So independent parameters, you can change or you can adjust your values. So that's called independent parameters. Okay. So that is what you have to match both the things. For dependent parameter, what are the independent parameters available and how it is satisfying on both the sides. The right hand side and left hand side of the equation should be balanced based on your way directly proportional or indirectly proportional variables. So today we will see the topic of dimension analysis of an equation. So equations by a dimension analysis. Okay. So we move to the topic now. So we will see the definition of what is dimension analysis. It is a physical engineering technique used to understand the relationship between physical quantities by analyzing their fundamental dimensions, typically mass, length and time. So usually the mass, length and time will take as fundamental dimensions. All the things that is available in the universe are measured between among these three parameters only: mass, length and time. So we will see based on this you are going to solve your analysis. I will repeat once again. Dimension analysis is a physical engineering technique used to understand relationship between physical quantities by analyzing their fundamental dimensions, typically mass, length and time. So mass, length and time, both the sides should be equated. The powers or squares are very directly proportional, inversely proportional has to be, balanced on both the sides. So that is the what mentioned dimension analysis definition. Okay. Now another we will have, next we will have fundamental units. What are the fundamental units we are having? So normal nowadays they are using SI units only for all our calculations. In SI units, especially fluid mechanics, so length is measured in meter, mass is measured in kg and time is measured in seconds. So this is the fundamental units what they are using and its unit. So MLT, so the mass will take it as M and length will take it as L and time it is S, time T. So MLT, so it's kg, length and time in seconds. These are things you have to measure. These are called basic dimensions. These are called basic dimensions. Next you have derived units. It's called derived units. You are combining two different fundamental dimensions, that is called derived units. Okay. So relation between two. So that is we take density is a mass by volume. Okay. So that is called derived units created by combining these fundamental units. So fundamental units means singly it will available. It will be in length, it will be in mass, but it will be in seconds. Derived means combination of two fundamental units. So describe fluid properties like pressure. Pressure is Newton per meter square. So there is two different units is here, and velocity meter per second. So that is relation between meter and second. And like density kg per meter cube, and viscosity, so Pascal second or kg per meter second. And flow rate, that is the discharge, meter cube per second. So these are all essential for analyzing your fluid properties. So today we are seeing about only fluid dimensions. So these are called fundamental derived units. And main we will take it as these are fundamental units. Normally length, mass and time, or mass, length and time. So symbol of fundamental dimensions is L and mass is M and time is T. So dimensions are also same, L, M, T. This is fundamental dimensions. Okay. Similarly, we will have derived dimensions. So this is fundamental and it is geometry. So which is used to measure. So area will take it as meter square. The unit of area is meter square. So meter is measured in meter and meter. So it is measured length into length. So it is taken as L square. It is taken as L square. Similarly, volume, unit of volume is meter cube. So L into L into L. So we take it as L cube. So volume is L cube. So meter cube, you are substituting L cube. Similarly, kinematic quantity, that is quantities which is varying depends upon time. That is called kinematic quantity. So that is velocity. Velocity unit is meter per second. So meter is L, per second is time, so meter per second. Similarly, angular velocity. So per second, we take it as angular velocity per second. So angular velocity, so it is per second means t power minus 1. Instead of 1 by t, you put t power minus 1. And acceleration, it is meter per second square. So meter is L, second square is per time, meter per second square. Then angular acceleration, so per second square. Similarly, discharge, kg per meter cube. Kg per meter cube. Then we are having acceleration due to gravity, meter per second square. Meter per second square is acceleration. So meter is L, per second square t square. So meter per second square. Then kinematic viscosity. So meter square per second. So L square per second. These are all comes under kinematic quantity. That is depends upon, you can see all are per second, something second will come in the bottom. So these parameters are measured in seconds. So it is called kinematic quantity. Okay. So similarly, on dynamic quantity, that is including your force, some weight or measured value will come. So that will be dynamic quantity. Kinematic quantity is only for motion per second. Dynamic quantity, now we are including some force value. So that is dynamic quantity. So normally force is taken as force equal to mass into acceleration. Okay. So take it as force equal to mass into acceleration. So mass is m, mass is kg measured in m. Acceleration is meter per second square. So meter per second square. So you take it as ml t power minus 2. Yeah. So if you are unable to find out what is force, if you know the formula for force, you can find out what is the dimension. So force equal to mass into acceleration. Mass you can directly write as m here. And acceleration, we don't know what is the dimension, so it is taken as kinematic quantity, meter per second square. Meter is L per second square, Lt minus 2. That is force. Similarly, weight. So weight and force both are same. Yeah. So both are ml t power minus 2, ml t power minus 2. Then density. Density is kg per meter cube. So kg means it is measured in mass. Kg is a mass per meter cube per length cube by L cube. M by L cube will put us ml power minus 3. So you should know the formula for all the terms also. Before writing the dimension, if you don't know the formula, you cannot write dimensions. So density is kg per meter cube, m by L cube. Similarly, specific weight, density kg meter cube. Specific weight is density into g, that is rho into g. We will take it as specific weight. To multiply the density value into g value, you get specific weight. Okay. So you multiply this value by meter per second square, you get m L power minus 2 t power minus 2 kg meter per second square. The kg per meter cube is the density, kg per meter cube is density, and meter per second square is g, acceleration due to gravity. So on combining this value, we will get m L power minus 2 t power minus 2. That is for specific weight. So dynamic viscosity, you take it as Newton second per meter square, or simply you can remember as kg per meter square. This will be somewhat easy to remember. Actually, unit is Newton second per meter square or kg meter per second. Kg is m per meter L per second t, kg meter per second. That is dynamic viscosity. Similarly, pressure density. So this is pressure Newton per meter square, and modulus all are Newton per meter square. All are Newton per meter square. So ml per minus 2 t per minus 2, ml per t per minus 2. So both are same. Pressure density Newton per meter square unit. Modulus of velocity Newton per meter square. Surface tension meter per kg per second square. So kg per second square, kg per second square. That is surface tension. Similarly, we are having power. So joules per second. So m L square T power minus 3. So joules is Newton meter per second. Okay. So once you know the fundamental of force or density or viscosity, especially these three, force, density and viscosity, you can easily solve other, these are all comes under other derived values only. So these are Newton per meter square. Once you know the Newton, you can find what is Newton per meter square for pressure. Okay. So these are all comes under power, torque. So torque is Newton meter. Okay. So torque Newton meter, you can find Newton meter. For Newton in value, you know Newton is force ml T power minus 2 into meter. So you get ml square T power minus 2. So I will tell once again, force, this force, density and viscosity. If you know these three, you can find out remaining easily. Provided you should know the unit for other values also. So these are all the previous one you need to require before going to any dimension analysis. You know the basic concept of this, it is very difficult to solve problem. So once you practice, it will come. You can easily learn. Okay. Now we see the another term, dimension homogeneities. Initially I told both the sides has to be balanced. Right hand side and left hand side has to be balanced based on the fundamental dimensions. The powers of MLT on right hand side should be equal to the powers of MLT on the left hand side. So that's what you are going to analyze. Okay. So we'll see what is dimensional homogeneity. It means that dimensions of each terms in an equation on both the sides should be equal. So as I mentioned, dimensions of MLT on right hand side should be equal to dimensions of MLT on the left hand side. So that's called if it is equal, then we will call that equation as it is a dimensionally homogeneous. Dimensionally homogeneous means both right hand side and left hand sides are homogeneous. So thus if the dimension of each term on both sides of the equation are same, the equation is not dimensionally homogeneous equation. You can call that equation as dimensional equation. You cannot simply put the term on left and right as you like. Okay, that's what it is mentioned. Suppose the scientists are finding a new factor, propulsion of rocket or propulsion of wind blade. So what are the parameters that will affect the propulsion of wind? So what is dependent, which is independent? We will find out the parameters first. And you have to find out the relation between each parameter. Which parameter increases, which parameter increases. Suppose increase one parameter, other parameter will decrease. So that's what the relation you are going to find out. Which parameter, if they increase one parameter, what will happen to the other parameter, whether it is decrease or increases. That's what. So decreases means it comes in the denominator or numerator. That's what we have to find out. So the powers of fundamental dimensions on MLT of both sides of the equation will be identical for the dimensional homogeneous equation. The powers of both sides are equal, then it is called identically dimensionally homogeneous equation. So such equations are independent of the system of units. So that's what that is called dimensional homogeneity. Okay. Any equation, anything, if you find out a new thing, the equation should be finally, as we concluded, should be dimensionally homogeneous. Okay. So normally you will use two different methods of dimension analysis in your fluid mechanics subjects. So from the olden days, you are following the same thing. You are following two methods. So one is Rayleigh's method, other one is Buckingham theorem. Okay. So the number of variables involved in the physical phenomenon are known. That is any equation or any functions of any body. What are the variables available? You can able to find out. Then the relation among the variables can be determined by the following two methods. I told the relation between whether it is in numerator or denominator, or whether it is going to increase or decrease when changing one independent parameter. Dependent is common. You can adjust your multiple of independent parameters. If you change any independent parameter, what will happen to the other parameter? That's what you are going to study about. So you will normally use two different methods. One is Rayleigh methods and another is Buckingham theorem. Okay. So these two methods normally we use, but especially we will see what are the merits and demerits of each unit, each methods. Okay. First you will see what is Rayleigh method. Normally there is a limitation for Rayleigh method is that This method is used for determining the expression for a variable. It depends upon maximum 3 or 4 variables only. So we can find out if the equation is very small, we can find out using Rayleigh method. The equation contains more than 3, 4, 5, 6, 10 number of variables are involved in a particular action or process, then we cannot use this. It is very difficult to find out the relation between the fundamental dimensions. So normally we will go with this is the drawback of Rayleigh method. The number of independent variables becomes more than 4, then it is very difficult to find out the expression for the dependent variable. Okay. So normally, generally we will go for Buckingham pi theorem. Today also I am going to explain elaborately about Buckingham pi theorem, since it can handle many independent parameters. Okay. So now we will go to Buckingham pi theorem. This is generally and normally used for dimension analysis in all our cases. Okay, this is called Buckingham pi theorem. So we will see what is the definition of Buckingham pi theorem first. What is mentioned. So Rayleigh method of dimension becomes more laborious. The variables are more than the number of fundamental dimensions. That is, if it is 3, independent parameters are 3, you can solve. The independent parameters are 4, difficult to solve. So we are going for Buckingham pi theorem. This is the limitation of Rayleigh's method. Okay. This is what the dimension units for definitions for Buckingham pi theorem. So we read carefully, or will be difficult to understand. Once you solve the problem, you will understand. There are n variables, that is both, you are calling both independent and dependent variables in the physical phenomenon, and if these variables contain m fundamental dimensions, then the variables are arranged into n minus m dimensions term. Each term is called phi term. Okay, if you take a particular process, we take one as dependent parameter and take it as a 7 or 5 independent parameters. So 1 and 5. So totally you will have 6 parameters now. That is called, there is 6 variables, for example, independent and dependent variables in a physical phenomenon, and if these variables contain m fundamental dimensions, always all the equations are MLT. So since already we have 6 parameters, the MLT. So normally you have always 3 fundamental units. Now totally we are having 6 and 3 fundamental units. Then the variables are arranged into n minus m. N is 6, m is 3. Total you have n minus m. You have to arrange 3 phi terms. You have to arrange 3 phi terms. This is the definition for Buckingham pi theorem. So we will elaborately understand when we will go to the problem. Okay. So I will go to the Buckingham pi theorem. Still more how to solve. So how to find out x? We will solve the problem x. This is the phi term. How you would arrange phi term? Phi term will be x2 power a1, x3, x4, x1, and phi 2 will be x2, x3, x4 till x5 maybe. You can arrange whatever you like. So these are all called repeating variable. This x2, x3, x4 are repeating variable. So of the 6, so for example, we have taken 6 means of the 6, one is dependent, leave this. Another one is 5 independent. In the independent 5 variables, we have to take 3 as repeating variable. 3 as repeating variable, that is called x1, x2, x3, x4. x1 is a dependent. x1 should be here, dependent will be here. x1, x2, x1, x2, x3, x4, x5. Okay, totally 6. One dependent on the right hand side here, we leave it as now you are having 5 parameters on the right, independent parameters. The 5 can be arranged as take 3 here, x2, x3, x4. These 3 should be, one should have geometric property, one should have kinematic property, one should have fluid property. So these 3 has to be selected. Okay. See, the final Lewis phenomenon is obtained by phi 1 like this, phi of this. Phi means some constant. This might be some constant. Okay. Still I will explain. Now we will go here. Each of phi terms is dimensionless and is independent of the system. Division or multiplication by constant does not change the character of the phi term. Okay. Any multiplication will not change the character. Each phi terms contain m plus 1 variable. Okay. M means 3. So you know m means fundamental elements, we have 3. So totally should have 4. 1, 2, 3, 4. We have 3m, MLT, 3 fundamental units plus 1 term should be there. Each 5 terms should contain m plus 1 variable. Totally 1, 2, 3 plus another 1 variable. This is m plus 1. Where m is the number of fundamental dimensions, so 3. And also is also called repeating variable. This should be repeating variable. This should be common to all the x1 and x5. So in the above case, x2, x3, x4 are repeating variables. In fundamental units 3. So this is what it is mentioned. So I will explain more to understand this. How to select the repeating variable? So you have to choose 3 repeating variable. I will repeat once again. So example you have taken as 6, 1 dependent, 5 independent. Okay. In the 5 independent, I am going to take 3 as dependent, 3 as repeating variable. So what are the, how we can select these 3? How you are going to select these 3? So some conditions given how to select the method of repeating variable. So as far as possible, the dependent variable should not be selected as repeating variable. Okay. Dependent means the right hand side. So that should not be a selected repeating variable. So as far as possible, even 100% don't go for repeating variable. Second, the repeating variable should be chosen in such a way that one variable contains geometric property. Geometric means length, breadth, width, volume, so area. These are all geometric property we have seen initially. So length, breadth, width, area, volume. These are all comes under geometric property. One should possess that one. And other variable contain flow property. Flow property means density, viscosity, discharge. These are all comes under fluid property. So that is flow property. And third variable contains, one is flow property and third variable contains fluid property. So this is flow property means velocity, density, this comes under viscosity and other properties. Okay, this is comes under viscosity and kinetic viscosity like this. So 3 you are going to select. One should contain geometry, another one is fluid property, flow property, third one is fluid property. So geometry, flow and fluid. Yeah. So these are all second condition. Third one is, so normally we will go with variables with geometric properties, length, diameter and height. So generally we normally use this. So all the equation may contain this parameter, length, diameter or height. So length is L, diameter is also L, height is also measured in L, length, meter. And normally for flow property, that is per second we need velocity meter per second, acceleration meter per second square. So these are the properties we will choose for our repeating variable. Third one is fluid property, for example viscosity, density, so angular, these are all things we use. Viscosity, density and discharge we use. Repeating variable should not be form a dimensionless group. That is, parameter does not contain any dimension. That is, take efficiency, not having any dimension. Okay. Any Reynolds number, Max number, these are not having any dimension. Take specific gravity, not having dimension. Strain, so change in length, original length, strain, not having dimension. That is Poisson ratio. So lateral stable, longitudinal strains, no dimension. Specific gravity, these are all not having any dimension. So that parameter should not be used. The repeating variable selected should not form a dimensionless group. We should not choose that efficiency, or strain, or Poisson ratio. These parameters should not come under this repeating variable. Okay. Now, no two repeating variables should have the same dimension. So you have 3. In this 3, all should have different variables, different dimensions be there. So you should have length, should have meter per second, or should have Newton meter per second square. So these 3 should have different variables. So this is the fifth condition is given, a method for selecting repeat variables. So repeat once again. As far as possible, dependent variable should not be selected, and you are choosing one should contain geometry, next you should contain flow property, third should contain fluid property. So this is second condition. Third condition, repeating variable should not have any dimensionless group like efficiency, and no two repeating should have the same dimension. repeating variable what you have chosen should not have the same dimension. This is what the methods of repeating variable. Okay. So in most of the fluid mechanics problem, the choice of repeating variable may be dV rho. That is, one is geometric, another is flow property and fluid property. That is diameter, velocity and density. Here length, velocity and density, or length, velocity or viscosity, or you can choose diameter, velocity or viscosity. These are all generally used repeating variable for our problems. Okay. Now I will repeat from the first one. Those who not understand, I will repeat from the start. So normally we go for dimension analysis. For all the dimensions or any equation what you selected should have right hand side and left hand side both should be balanced in terms of dimensions, M, L, T. So that is called based on the independent dependent parameters. You have to find out, you have to analyze whether it is equal, RHS equal to LHS. That you have to analyze. That is called dimension analysis. That is means whether it is directly proportional or indirectly proportional or in square or cube. So how it is related between one parameter and another parameter. That's what you are going to find out between dependent and independent parameters. Okay, that's what dimension analysis means. So you have seen what is the meaning of this. So relation between physical quantity is a technique used to find a relation in technical quantities. That is called dimension analysis. Then you have seen fundamental units. What are the three fundamental units? Mass, length, time. These are the fundamental units. Then relation between two units called derived units. That is Newton per meter square, meter per second, kg per meter cube, discharge, meter cube per second. All these are called derived units. This is fundamental units. This is derived units. You have seen. Then these are comes under MLT. This main MLT. These things you have seen. Then you have seen geometric. What is geometric property? Area, volume example. Then kinematic quantities. That is flow property. So all you will have some per second. That is velocity, angular velocity, acceleration, discharge, due to gravity, kinematic viscosity, all comes under kinematic quantities. Then dynamic quantities, which comes under force, which comes under pressure, we take it as. So normally force is main here, m/t power minus 2. So force is mass and acceleration. And density, kg per meter cube. So dynamic viscosity, Newton, second per meter square or kg meter per second. These three very important: force, density, kinematic viscosity. You know these three you can find out remaining here also. All power, torque, everything you can find out. You have seen these are dynamic quantity. Then you see the other term, dimension homogeneity. If both the units top and bottom is equal, is balanced between the M, L, T and both the right hand side balance, it's called dimensional homogeneous equation. All the equations what you are deriving or solving should have dimensionally homogeneous. Okay, that is main important. If it is not dimensionally homogeneous, you cannot solve the engineering technique. That concept what you develop cannot be used for our solving any solutions. That is called dimensional homogeneous equation. So when you are creating equation, you should be careful. You should have dimensionally homogeneous. Okay. So you are going to solve dimension by two different methods. One is Rayleigh method, another one is Buckingham Pi-Therem method. I told Rayleigh methods suitable only up to 3 variables. Buckingham Pi-Therem can be used for n number of variables. Okay, so we have limitations for Rayleigh methods, and you see the definition for Buckingham Pi-Therem. There are n variables in an equation, and it contains m fundamental dimension. The variables are arranged in n minus m dimensional term. Each term is called phi term. Then we have seen how to select the phi term and what are the parameters that should be taken for method of selecting repeating variables. So 5 points has to be taken care of. So one, flow property, fluid property, and fluid property has to be chosen for our repeating term. Okay. So no two repeating should have the same dimensions. These are the main thing. Normally you will choose. Remember this. Normally for the choice of repeating variable, dv rho or lv rho or lv mu or dv mu are chosen as a repeating variable. So carefully you should choose what is the repeating variable parameters. Okay. So these are all, if you understand this property, you can find out what is your, how you can easily solve your Buckingham pi theorem. Okay. So in the next video, I will solve about one problem based on the Buckingham pi theorem. Okay. Thank you.